guys, limits at infinity again, so part 2. Yesterday we did questions 1 through 3, and then we talked a little bit about the concept of infinity. So today we're going to work on a couple more examples. So think about what if we were to substitute x with a really big number, let's say 1 billion. 6 means nothing compared to 1 billion. And that's how we're going to treat it. But how do I know that? Well, we're going to estimate our answer, and then we're going to prove with our pretty little work over here. And, you know, after you do a couple of them, you're just going to get quicker about proving and showing your work. Okay, so if this means nothing, so what really matters is what this is. And then we're going to have to compare the limit as x approaches negative infinity of -9, and then times the limit as x approaches negative infinity of x. So it's either going to be positive infinity or negative infinity. Okay, but which one? Well, here we go. So before we do anything, I need to factor out x. What does that mean? Well, if I have x right here, factoring it out means I have this term, -9x, divided by x. That gives me -9. Plus 6 divided by x is 6 over x. Okay, so I just rewrote this function differently. And that's what we're going to do. So I will find the limit as x approaches negative infinity of x. And then times limit as x approaches negative infinity of this guy right here. So -9 plus 6 over x. Now, from yesterday, we had this chart. And I know that if it's bottom heavy, that will equal to 0. Just think about if I have $6 to divide among, I don't know, 10 billion people. Pretty much everybody's going to get close to $0. Okay, so every time is bottom heavy, this will be 0. Okay, how do I know that? For this reason right here. So it doesn't matter if the exponent is positive or negative, bottom heavy, that's always going to be 0. Okay, now I need to evaluate this limit. So right here, so negative infinity. This chart is from yesterday. So negative infinity there times the limit of a constant is the constant. So -9. When the signs are the same, then positive infinity is your answer. All right. Now this one, if numerator and denominator have the same degree, then your answer will be just the leading coefficient. So I have -8 over -1. Voila, simplify, the answer is 8. Okay, but how do I know that, and how can I prove it? Well, I will factor out x from the numerator and also factor out x from the denominator. So x from the numerator, -8x divided by x. I have -8 plus 10 over x right there. And then I'm going to do the denominator right here off to the side. Factor x out. -x over x is -1. And then -7 over x. Okay, so now I will rewrite this function as 2 limits. So I have the limit as x approaches infinity of, right here, this one is the numerator, so x. And then this is the denominator. Okay, at this point I can go ahead and split that in 2 limits. One is the limit as x approaches infinity of x over x, and then x limit as x approaches infinity of what I have left over right here. It looks like this. So x over x, and then I multiply by the limit as x approaches infinity of negative 8 plus 10 over x, negative 1, minus 7 over x. Okay, I know this I can simplify. So x divided by x is 1, and I know the limit of a constant is the constant, so here I have 1. Now, bottom heavy right here, so this is 0, this is 0. Now I have just a constant, so the limit of a constant is the constant, so negative 8 divided by negative 1 is positive 8, and 1 times 8 is 8. Okay, so right here, the exponent in the denominator is definitely greater. So the degree of the denominator is definitely greater. So I know at this point, bottom heavy, my answer will be 0. Okay, but how can I prove that? Well, here we go. I would, if I have any degree, any x, any variables on top, I would have to factor out the x, but I don't. So I will leave the numerator alone for now. I will factor out x cubed from the denominator. So I'm going to do that right there. So factor out x cubed. I have 5 minus 8 over x minus 10 over x squared, and then 3 over x cubed. How do I know that is true? So when I'm factoring out, in reality, I'm dividing the term by the x cubed. So 5x cubed divided by x cubed, I can simplify them down to 5. Negative 8x squared divided by x cubed, the exponents simplify, I have x left in the denominator. Okay? All right. Now here I have the limit as x approaches negative infinity of 1 over x cubed. Why is that 1 over? Well, because it's in the denominator. Okay, I have 1 over x cubed that I factored out. And then I have 9 on the numerator, and then everything else right here that I just got the factors. Okay, and you know I can at this point split that in two limits. So this is also the limit as x approaches negative infinity right there. Okay, now from my chart, where'd it go? I have my chart right here. So it's approaching negative infinity. But does it really matter? So I know when it's bottom heavy, this is going to be 0. So I have 0 right here. And then I also know all of these bottom heavy right here, they are all zeros. So at this point, I have the limit of a constant, 9 over 5. 0 times anything is 0. Last one. I think you guys have been waiting for this one. Now, I have this, in this case, I don't have bottom heavy. So I have my numerator. The degree is greater on the numerator. I'm still going to go through the process of, I'll factor out x squared on the numerator, and I'll factor out x in the denominator. So I'm going to do that right here off to the side. X squared is negative 7 minus 10 over x plus 2 over x squared. And then I will factor out x from the denominator. So 5 plus 7 over x. And then I will do the split of two limits right here. So I have the limit as x approaches negative infinity of numerator over denominator. So x squared over x times the limit as x approaches negative infinity of whatever I have left over. So negative 7 minus 10 over x, and 2 over x squared. Okay, bottom heavy, those are all zeros. Now, what do we do here? So I can simplify x squared over x as just x. So here I have the limit as x approaches negative infinity of just x. And here I have the limit of a constant, so negative 7 over 5. Okay, so here's my chart. Right there. So negative infinity times negative 7 over 5, same sign, so positive infinity right there. I'll see you later.